In our previous video, we talked about the fact that when we're trying to find the domain of the composite function, there are two things we have to look for. The first one is that g of x must be defined. So in other words, we're going to have to exclude any value that's not in the domain of the input function. And we have to exclude any value that causes the input function to result in a number that's not in the domain of the other function. And our previous example, both of the original functions had a domain of all real numbers, so we really didn't have to worry about any of this. But let's look at an example where that's not the case, and let's see what we're talking about when we discuss the two different pieces that we have to look for. So as far as the composing goes, we're going to do it exactly the same way that we've done all along. We're going to use one of the functions as the input for the other. So in part A here, we want to find f composed with g. So remember that that is f composed with g of x. So that is f of g of x. So we're going to use whatever g of x is as the input for f. So in this case, we're told that g of x is 4 over x minus 1. So we're going to find f of 4 over x minus 1. So everywhere there's an x in f, we're going to replace it with 4 over x minus 1. And you may be tempted to stop there, but we never want to stop when we have a fraction within a fraction. So our last step here is going to be to simplify this so that we no longer have a fraction within a fraction. In order to do that, we are going to multiply the top and the bottom by the exact same term, because remember, we can multiply by 2 over 2 because that's equal to 1, and multiplying by 1 doesn't change anything. Or we could also multiply by x minus 1 over x minus 1, because again, as long as it's the exact same expression on top as it is on bottom, it's equal to just 1, and we're not actually changing the value. So in this case, because the inside denominator, so the fraction that's inside the other fraction, has a denominator of x minus 1, I know that I want to multiply by the top and the bottom by x minus 1. And I have to remember that I'm going to multiply every term on top and every term on bottom by the x minus 1. So on top, I have 1 times x minus 1, which is just x minus 1. On bottom, I have two different terms, so both of them have to get multiplied by the x minus 1. So what I like to do is to go ahead and write it twice so I don't get tempted to forget to multiply one of them. So when I multiply x minus 1 times 4 over x minus 1, remember this is like over 1, so the x minus 1's on top and bottom divide out and leave me with just 4. And then over here on the right, when I do 2 times x minus 1, I have to distribute my 2. So I get 2x minus 2. I can combine my like terms on bottom, so I get x minus 1 over 2x plus 2. So the composition function of f composed with g of x is going to be x minus 1 over 2x plus 2. Now, finding the domain for this composition function, however, is going to be a little bit tougher because the original functions do not have a domain of all real numbers. So let's go back and find their domain as our starting point, and then that's going to allow us to be able to find the domain of our composite function. So for f of x, we have division involved, and remember, we cannot divide by 0. So what can x not be so that our denominator doesn't end up being 0? Well, x cannot be negative 2. So for f, the domain is all real numbers except negative 2. And for g, again, we have division. We cannot divide by 0, so x cannot be 1. Otherwise, we end up with a 0 on the bottom and an undefined answer. So I know that there are two things I have to look for. The first one is that I have to exclude anything that's not in the domain of my input function. So in this case, my input function is g because the input is always listed second. And what's not in the domain of g? 1. So I know that my domain for the composite function cannot include 1. That's step 1. Step 2 is, okay, now that I know what I can't include because it's not in the domain of g of x, I have to look at what can I not include because it causes g to not be in the domain of f. Because remember, what are we doing? We're taking g of x and we're plugging it into f. Well, what can we not plug into f? We can't plug -2 into f. So if g of x equals -2, then we have a problem. So in addition to not including the 1, we also have to make sure that we do not include any x value that causes g of x to equal -2. So I'm going to come to the side here and I'm going to say I do not want 4 over x minus 1 to equal -2 because then we run into a problem when we try to plug it into f. So how do I solve this? I start by multiplying both sides by x minus 1. X minus 1's divide out or cancel, and I'm left with 4 is equal to -2x plus 2. And remember, this is what we don't want x to be equal to. Subtract 2 from both sides. 2 can't equal -2x. Divide both sides by -2. And x cannot equal -1. So my domain cannot include x equals 1, and it also cannot include x equals -1. So my domain is -infinity to -1, unioned with -1 to 1, unioned with 1 to infinity. Now, if that was confusing to you, you can always just look at it as, okay, find the input. Input is G. Whatever's not in its domain, exclude that. And then take whatever your input function is and set it equal to anything not in the domain of F and solve. And that's always going to account for both of the scenarios. All right, so our next example here is going to be very similar, but we're going to go ahead and work through it. Notice that the difference here is that we are not composing F and G, we are composing F and F, but the process that we use is going to be exactly the same. So F composed with F of X is going to be F composed with F of X, which is F of X. If we go back up here and look, we see that f of x is actually equal to 1 over x plus 2. So we're looking for f of 1 over x plus 2. So everywhere there's an x, we're going to replace it with 1 over x plus 2. Remember that we do not want to leave a fraction within a fraction, so what do we need to multiply both the top and the bottom by? We need to multiply it by x plus 2. So each term on top gets multiplied by x plus 2. Each term on bottom gets multiplied by x plus 2. So we end up on top with x plus 2. On bottom, these divide out and leave me with 1. Distribute the 2. So we get plus 2x plus 4. Combine our like terms, and we get x plus 2 over 2x plus 5. So f composed with f of x is going to be equal to x plus 2 over 2x plus 5. Now we need to find the domain. So in order to do that, we're going to think back to what was the domain of f, the original f of x function. X could not be 2, or sorry, could not be -2. So we have to exclude -2 from our domain. And we have to exclude anything that makes f of x equal -2. So multiply both sides by x minus 2. We get 1 is equal to -2x plus 4. Subtract 4 from both sides. And suddenly my computer doesn't want to cooperate. So I get -3 is equal to a -2x. Divide both sides by -2. And I get x cannot equal 3/2. So my domain is all real numbers except -2 and 3/2.